That's a rabbit hole in itself to find the right intersectional collaborations here. Which one are the most interesting ones? And is that serendipity as well? Which one emerges? Or do you see, I really need to get the handle of the education dimension of AI? Or how?
No, I mean, well, not for me at least. I'm kind of interested in most things. Yeah. So it's more, you find a person who are doing, for example, education research, and then you happen to have an opportunity to apply for funding, or they have a Ph.D. student or something like that, and then you start collaborating. So maybe it's more the Erdos kind of approach. You move around, you do a little bit of work with someone, and then you move on to the next person, and then do something there.
Going back to how you became the Professor Chair Sweden, can you just talk a bit more about that journey? How did that come about?
Yeah, that was a pretty long story, but I mean, it started out with, I mean, I have a lot of collaboration with Saab, and they have this deal with Brazil with the Gripen fighters.
Right.
And I mean, I have two industrial PhD students working on different types. So actually, Saab is a very good company to collaborate with when it comes to research, because they have like a 40-year life cycle, or product life cycle, and you don't work close to the product. There is no kind of pressure that you have to deliver something that's close to the product, but more, we need competence in this area. And for example, we do a lot of work on multi-agent reinforcement learning together with them. So it's more about building up competence in this kind of collaborative autonomy and collaborative problem solving. And then also Ericsson is involved. So again, they have a lot of activities in Brazil since a long time ago, and they have Ericsson Research Lab in Brazil. And so then the idea was that we connect the kind of research that we're doing here in Sweden, and then building up collaborations on the Brazilian side. And
is it like a formal position at some university in Brazil?
No, so then that's not a good thing. It's not at a single university, but it's actually part of an organization which is the Center for Sweden-Brazil Innovation. So there is an organization in Brazil that's a partnership organization. So the intention is to collaborate with multiple different, both universities and companies and so on. So I get the benefit of traveling around and visiting interesting research groups and see what kind of collaboration we can set up. And
it's a nice excuse to get some sunshine in these times of challenging weather, as we have in Sweden these days.
I like the Swedish weather.
Oh, you do?
Yes.
Did you get hit in Linköping by the snowstorm the other week, equally as we did?
Yeah, I mean, it was the same, right? Earlier this week, yes.
Earlier this week it was.
Yeah, I think Sunday or maybe Saturday.
Yeah, and you have already fixed the winter tires on your car. You were not hit hard.
No, we'll do that on Saturday.
Okay, so you're like me. We fix it now.
Actually, we had booked the time before, but yeah.
But it was
1 week too late.
1 week too late.
Cool. Well, with that, I'd like to welcome you here, Fredrik Heintz. It's a true honor and pleasure to have you here finally, I would say.
Thank you.
We've known each other for quite some time. We actually did the PhD basically at the same time, approximately, I think. When did you start your PhD? Was it
2000?
Same. And at the best university, right?
Of course.
In Linköping University. I think, in my view as well, at least, you're one of the best and the most famous AI experts we have in Sweden. So that's a real honor to have you here. I mean, you have so many different roles as well that you have. I mean, of course, you are a professor at Linköping University, and that was like a year ago or something, or yes?
Yeah, more than a year.
Yeah. And so many other things. I mean, you're a member of a European high-level expert group. Yes, in AI. I think we will get back to that shortly as well. You're also part of the WASP graduate school, right?
Yeah, I'm the director of the graduate school.
That as well. That's another awesome topic that we'd love to get more into as well. See if I can remember. You're president in so many things. President of the Swedish AI Society as well. And yeah, the list goes on.
You have too much fun, Fredrik.
Yes.
And of course now also since like a couple of weeks, 2 weeks, you're a professor chair of Sweden in this kind of Sweden-Brazil collaboration, or what should we call it? It's a
the whole purpose is to build up research collaboration between Sweden and Brazil in the areas of AI and autonomy.
Yeah, I mean, awesome. But let's take a step back, I think. Who is really Fredrik Heintz? For people that don't know you, how would you describe yourself?
I don't know. This is the hardest question. Yeah.
It is.
Take your time. What doesn't? I mean, I know your like professional part, but is it something else that people don't know that they should potentially know about you?
Well, I mean, I usually say, I like wine and wine tasting, and I compete in wine tasting.
Oh, really?
Wow.
So that's kind of
how do you compete in wine tastings?
So it's about blind. You get a number of different wines, and you're supposed to figure out what grape it is, what country, what region, and so on and so forth. And then you have to know. Yeah.
How did you get into the wine passion?
Yeah, actually it was a colleague. So we have this organization, Munskänkarna in Sweden.
Yes.
And he invited me to one of their activities, and then I got into their courses, and I think
the rest is history.
Yeah, but I didn't know anything, and I don't think I was that much of a wine drinker before. And but then when you learn something, you actually understand a little bit, then it becomes much more interesting.
And you appreciate it on a different level, of course.
Yeah, and I think there's other interesting things because, wine tasting is a very sensoric activity, and the really difficult thing is how do you discuss about sensor impressions, which means that in some sense the purpose of these courses is really to establish a common vocabulary on flavors or smells and tastes and so on. And then you start to be able to put words on this. And then when you're able to put words on these kind of abstract sensoric impressions, then you can start discussing and you can start analyzing. So actually I think there is some kind of connection to AI-related activities, but building vocabularies and languages and then being able to use them to discuss and learn more about these things.
What would happen if someone built an AI wine tester and that beats any kind of human expert? Would you be happy or sad about that?
Well, I think from a person perspective, it would be kind of irrelevant. But actually, we did research on that at Linköping University in the 90s, I think. So actually, they had both a artificial nose, and of course, they were building like an expert system on wines and being able to identify basically based on the purpose was, of course, the goal was to, based on the smell, being able to identify what wine it is.
Mm. Just the smell, not the taste at all.
I think that was only smell, yeah.
Mm. So you're not afraid about that humans can't beat computers anymore in chess or something? That's not something that discourages you from playing chess? Or
I've never been. Actually, I was a member of a chess club when I was like third grade or something, but I'm not a good chess player. I'm not particularly interested in it either. I don't think. Of course, the question is why do you want? I guess it's more the analogy is towards sports, and you can have sports in kind of with or without different types of tools, or what are you competing against? There's no point in racing a car. A human would never be able to run faster than a car. Still, we find running, or the sprint still is relevant because it's the kind of fastest human. Yeah. And then you can start to have these kind of hybrids, like people with prostheses that may or may not make them run faster. Then it becomes a bit more tricky. Where do you draw the line? When does it become cheating? And then you can argue, well, they do this kind of high-level altitude training so that you get used to the low oxygen, and then when you kind of run on normal oxygen, then you get the boost out of that. Is that cheating? And I mean, actually, I think this, where do you draw the line between cheating and what kind of within the boundaries is both interesting and blurry.
If you think about sports, in 30 years or something, I mean, today we have different classes in sports. It can be boxing and weight classes or whatnot, and gender and who knows. Do you think it will be a time where you have like one class that is like pure human class? This is augmented humans and machine together, pure machine competing against each other. Do you see that being a future in sports?
Yeah, that seems reasonable. Yeah, why not? I'm just trying to figure out what would be the interesting. I mean, of course, you can create a lot of categories, but which one would be interesting? I think that's the hard part. I mean, usually to make it interesting, it should be relatively even. I mean, if one whatever is kind of so outstanding, then it becomes kind of uninteresting. So you have to have some. And I also think that it should be different. I mean, it's kind of boring if the same team or person always wins. It should be, sometimes they should lose. So you also have to have a bit of change and diversity over time. And yeah, but I mean, I think personally I would prefer sports which are a little bit less kind of material dependent and more competence and training.
You wouldn't see any joy in. There is this league for like racing around the track with cars. I saw the NVIDIA pure, fully automated car once in the one of the NVIDIA conferences, and I saw this awesome-looking car. I was like, extreme like racing car, and I went closer to it, and I saw. Shit, there is no place for a human in it. There is no seat, there is no wheel to turn. And it's fully automated. And I actually became a bit sad because that means I can never drive that awesome looking car. But at the same time, it's fun to see, then AI racing each other.
But then now we have shifted what is the allure of the sport from mastery of a skill or physics of the human to really, to some degree, mastery of the mind, to of complex problems and solving it technically. Then it becomes a fundamentally different sport, which has an interesting aspect from a completely different angle, I would argue.
Yeah, I agree. So I had two comments. First about racing cars, because I had an interesting conversation. We were visiting Stanford a few years back, and we visited their racing lab. And I mean, they have a racing car there that has been racing up the Pikes Peak in the US. Yeah. And I mean, they said that, I mean, we have optimal control. We know that the car is working optimally, but still it lost. And why? Because that humans are always on the limit. So in some sense, they were always testing where do the limits of the surface go. I mean, how much friction do I really have? How fast can I take this curve? And in some sense, they're not driving. They're driving beyond what is they safely guaranteed can do, which means that the autonomous race car, which was driving optimally, but within the boundaries,
so it's some kind of
still didn't have a chance. So I really think this is when you want to have optimal performance, which of course you do in sports. It's not about being kind of within the boundaries. It's really about finding out where the boundaries are. And in some sense, in the biggest event, I mean, largest extent possible, kind of be beyond them in some sense. And I really think that's something you have to take risks. Actually, I think risk is very interesting. So I have a PhD student who's working on this risk-aware reinforcement learning. Oh. And because, I mean, in some sense, in many cases, you have to take risks. There is no way that you can kind of succeed, at least without running the risk of kind of completely failing. I mean, taking this race car example, of course, if you drive too fast in the corner, you might just slide off the track. But if you don't do that, you just drive safely, well, you will finish, but you will not win. So in order to have a chance of winning, you really have to sometimes drive faster than you don't know if it's really safe or not.
But can you really call it optimal if you don't also include the risk of crashing?
I mean, it's optimal within the model that they use.
But I think this is interesting because it becomes then a topic that we can build models with less risk or no risk or whatever, or we can have people working within the boundaries of what we know is possible. But what is intriguing is that humans have always seemed to push the boundary of what is possible, or what now you can never run faster than 10 seconds. Actually, we could do 9. And this striving for the next level, of course, when you are at the boundary or above the boundary, to model that is ultimately to model in a certain amount of failure in what you're doing in order to see where the limit is. So you can't do a safe model that is not, if you want to push the boundaries. You need to have a boundary which is, you need to have the risk in there, but it doesn't go. You can't avoid it, of course. So, but it's really interesting thinking because it pushes us further.
Definitely, and I think there are many aspects there. But I mean, one is of course modeling the uncertainty, and within the uncertainty, you can kind of make a trade-off between some kind of safety and utility.
Yep.
But that again is a very kind of still I would say kind of safe approach. But I think finding out where the boundaries are, I mean, in some sense, it's more about active learning, because you have to. I mean, you might know I can drive this speed. I know I can do pretty safely. But what happens if I add 5%? Is it still safe? I don't know. And of course, you might have your tires get warm, and then your friction reduces, and then it's more a model uncertainty that you might not be able to model everything with detail enough to actually, even if you had the full models. I mean, then of course you get into this more epistemic and allegoric uncertainty. What are things that we just doesn't have enough information about, but we could know, and the things that we couldn't even be able to know. There's no way of finding out in some sense, or knowing in advance.
Very interesting.
How did your interest in tech or AI get started?
So, I mean, I was very much interested in optimal rational behavior, I think in, I don't know, middle school or something.
Really?
Yes. So my goal was to be optimally rational.
Oh.
How did you find that? What's the angle when you're that young to think like that? Where did you pick that up? Did you read something? Do you remember it?
No, not really.
It was just the way you were thinking about schooling and your life.
Yes, apparently. But yeah. No, and also, I mean, actually I think it was kind of interesting because I found it difficult to interact with people because they were so unpredictable and...
it's better to interact with computers, right?
Yes, exactly. And the funny thing is, I mean, then you thought, computers, you can kind of understand how they work. You can know roughly what will happen, and you can kind of control the interaction. But then over time, I kind of came to almost the opposite conclusion. I mean, in some sense, I work much more with people than computers these days. And in some sense, I mean, computers are as unpredictable, and maybe when the kind of complexity and sophistication of these machines or the computer, I mean, the programs and everything else becomes very high, then they also become unpredictable. And interaction with people is much more fun.
I must say personally, if there is one field I wish I studied, it would be psychology these days. I haven't studied it, but it's an amateur interest of mine at least, and trying to understand the complete irrationality of humans is, I think, a very fascinating topic. Would you agree?
But the question is, are we irrational or are we just bounded rational? In the sense that, I mean, from an external viewer perspective, we look irrational, but maybe the decisions we make are perfectly rational given the limited knowledge and information we have, and also computation time. So actually, I think something that's very interesting, I think, is this the relation between computational time and making decisions. Because, I mean, in many cases, we focus more on what you know. I mean, it's more, did you know that fact or not that fact? And if you knew something and acted against that, then we think it's kind of strange. But it could also be that it just takes too much time to find out what the right thing to do is.
So this is an interesting part. I mean, I would argue, and I think so many people don't speak about the limits of human mind. And I think one is the limited, bounded rationality that we do have, and the lack of our ability to focus, the limited memory abilities that we have, which is extreme, I would say. But if we take, one way to speak about the human mind and their capabilities is the different type of logic you can apply. You can think about deductive logic, inductive, and abductive logic, if you know the three. And just to go through them very quickly, I mean, deductive is basically saying, given I'm a man, all men die, that means that I must die. That's a deductive kind of, complete logical conclusion that you can reach. But then you can have other types of reasoning that is illogical, like inductive, saying, I've seen 100 birds fly out of the forest, all of them were black. That must mean that all birds are black. It's not deductive, but given all the information I've seen so far, it seems to suggest at least that you have some conclusion that all are black. And then abductive, you can, and please correct me if you have a better definition for it, but it could be saying that I haven't seen any proof that God does not exist, therefore God exists. I jumped into a different...
I think that's completely... Isn't that more this... I've got the name, but I mean that negation. But anyway, abduction is more diagnosing. So it's like you have a world model and you have an observation, and that observation does not deductively follow from the world model. Now the question is, what do you need to add to the world model in order for the observation to be a logical consequence of your world model plus this new information? And that's the diagnosis problems. I mean, you go to the doctor and you have some symptom and they say, oh, what's wrong with you? And that's the added thing they need to know in order to explain explain your illness.
That's a more politically correct, I think, definition. My point a bit was, I mean, some people at least define adaptive logic as something that as long as you can't prove it wrong, you believe it's to be true in some way. So it's like the opposite of, not opposite of inductive logic, but at least it's something that you may have a strong bias to believe in something, and no one has proven me wrong, therefore I can continue to believe in it. But no matter how you define it, some people say that humans conduct 70% of their reasoning in an abductive way.
So isn't that more default reasoning?
Yeah, could be.
I mean, you have a default, and then unless you have some, abnormality condition satisfied that violates the default assumption, then you can assume the default.
But on the topic of psychology, I read Atomic Habits. Have you heard about this?
Yes.
Have you read it?
No,
but it's quite interesting how, this is not very scientific, but I think it's a good read, how he breaks down what is seemed to be irrational behavior. We're talking about humans are irrational, but if you actually understand what is driving humans, or what is driving and shaping our behaviors, and you understand them, then something that looks from the outside as very irrational is rational from the point of view of the person making the decision. So, we can talk about you need to stop smoking, you need to eat less, you're gaining weight, and why, is it something irrational with this person compared to that person, why this guy is fit or doesn't smoke and this person does it? And what I find interesting with this is breaking down to really understanding how behaviors are shaped and formed, and how you need to then, to solve this problem, you actually need to work in another part, how the behavior is shaped. Ergo, we are not irrational. We are completely rational from our internal system of understanding the problem, or our behaviors, or what is shaping our motivations. So it's way deeper. And for me, psychology is a little bit like understanding what is actually rational from the point of view of the other person. Sometimes if we can dig into the behavior and what has shaped the behavior, it becomes, it's not so irrational.
but isn't that also a question of preferences and what we value?
Exactly. So,
and I mean, you might have So, I mean, there are different ways of satisfying your preferences. And
Yeah, exactly this. So if I take one example.
And abductive reasoning.
No, but one example, right? If you truly want to become fit, then you need to shift your identity from I'm a couch potato to my core identity is I'm a fitness person. So how would I now model myself? And so you need to, if you really want to change behavior, you need to go back to remodel your identity. So you need to go way, way deeper on your preferences in order to get to the actual irrational behavior of eating too much. I think this is what is the core here, that there are layers here, right? So,
I mean, if we're going to connect that back to AI, I think one challenge with many AI systems today is, I mean, they're optimality based. So you have some kind of notion of optimality, and then you're trying to optimize, or I mean, in some sense, a objective function or objective that you want to maximize. And then the question becomes, how do I maximize this? And I think as humans, first of all, I don't think we have one single
objective.
Yeah, exactly. We shift objectives both kind of during a lifetime. So in some sense, I would say your behavior change there requires a change in what our objective becomes. But I also think we change objectives over the day. I mean, when at work, we have different objectives than when we're at home or when we're on vacation or we're traveling and so on. I mean, then we have very different objectives. And I actually think what's interesting is that all the time, even though our objectives changes, in some sense, the system or if you call it model or whatever that we are is still being optimized. So in some sense, you're changing your behavior depending on the objective, but the experiences and what you learn from that stays with you, which means that you can take advantage of the things that you learned while you have one objective function when you try to pursue a different objective function. So I actually think that we will get much more interesting systems if we actually kind of vary what we maximize or optimize for. So at different time points of the system, you optimize for different things, but you're still improving the same system. And I think that would be interesting. And of course, we also do research on multi-objective reinforcement learning and multi-objective decision making. So that I don't believe that there is a single kind of scalar valued objective, but rather we need to have a more vector-like objective with many different kind of criteria, and then what we care of or how we kind of weight this together depends on the situation. And I think
the person or the machine, perhaps, or agent, if we speak more generally.
Yeah. But let's just see if I follow this right now. The problem becomes when an agent is, so to speak, an orphaned. So when you have an orphan object, you have one agent with a very with an objective on its own. And when you're looking at this now with multi-objectives or different, it's actually about understanding we have different systems. They might have different objectives. We have one, I don't know how.
Or the same system with multiple objectives. But
Then that becomes much more interesting. That becomes much more nuanced. As long as you have a single objective with a single system, it becomes quite narrow.
I would say my argument, or at least one of my arguments, were that even if you have one system that you want to make as good as possible, you may benefit from actually switching between different objectives that you try to optimize over time. Even though, in some sense, you might want to, be the fastest runner on the planet, but you might benefit from, I also want to be strong, or I want to have other things, and then you optimize for other things, and then you go back to being the fastest, and then you benefit from that as well. So it's more this. In some sense, this single-mindedness of just having a single objective function that you just mindlessly try to achieve. I don't think that's healthy.
How did that? Okay, so you started with the optimal, rational behavior, and that got you interested in AI, I guess, or tech in some way. How did that continue? How did that lead to your starting your AI career, so to speak?
Yeah, so as I said, that was more in, what do you call it, högstadiet, or maybe something like that.
College, high school.
In high school, then or after high school was more the question what to do next. And then I had very many different choices. I mean, should I go the more complex system, the more kind of physics and mathematics based approach, complex adaptive systems, or should I do the more, physics approach, or the more cognitive psychology approach? But then I found this computer science program in Linköping and that was kind of perfect because they had like 1/3 math, 1/3 computer science, and 1/3 cognitive psychology, linguistics, and so in some sense I could get most of the things without choosing. So then it was a pretty easy choice. And actually, Linköping University is also where AI research started in Sweden. And I mean, we've been doing AI research for more than 50 years. So it was kind of,
right?
Yeah, exactly,
so
70s.
Who is the grandfather here? I think you mentioned
Erik Sandoval.
Yeah, Sandoval.
So that was your supervisor.
Yes, it was.
So
in Sweden, yeah, but in the world, there's a lot about.
No, but I was referring to Sandoval. That I know.
Yeah, so he was the first professor of computer science in Sweden, and he was over in the U.S. in the late 60s studying with John McCarthy and Marvin Minsky. And
he worked with the bigs.
Yeah, exactly. Cool. And then when he came back to Sweden again, he became the first professor of computer science, and started up computer science in Sweden. And then AI was a natural part, which is actually interesting because AI has been part of computer science from the start, but the kind of downside or kind of side effect of that is that AI has always been part of it, but not maybe something of its own. So it's been a little bit hidden.
But maybe interesting angle. What's the pros and cons, or why should AI be part of computer science and why should it not be?
I mean, I would say technically it is part of computer science, and it's not a question of whether we want it or not, but because in some sense it's about, actually I think, going back to the foundation of computer science is also interesting, because you can argue that, the work of Turing was in some sense the start of computer science. And what did he want? He wanted to use the computer to solve his problems, so he didn't have to do them and do them faster than he could do. And so in some sense, computer science has always been about how do we get the computer to solve problems for us, and turning kind of what we as humans do into computations so that we can just compute the answer. And of course that goes back to Leibniz and let's compute and all of that. But and of course Turing also wrote this paper, Can a Machine Think, in the 1950s. So actually I think computer science and AI is very tightly intertwined. So in some sense, I guess the rival would be cybernetics, which then turned into control. So actually, when Wiener, control theory. So when Wiener started out the cybernetics, then at the same time, John McCarthy wanted his own thing. So then he had to come up with something different. And then he came up with AI as a kind of alternative to cybernetics.
Should we go there here? I think the name AI is rather controversial, and as you say, there is an interesting history behind it. And
let's really take the origin now, because we have so many definitions that are vague and hyped. So let's go back to this when we have the chance to talk about this, where it all starts. I think it's super good.
So we have John McCarthy, that also I think coined. I think most people agree that he coined the term in 1956, I believe it was. And as you said, I think he did it for reasons such as he wanted to find a different name than cybernetics, and then he came up with some term called artificial intelligence. What's your thinking? Is that a good term to call what we today are building in artificial intelligence?
Yes.
Is AI a good name?
Sure.
That was a surprising answer, but okay.
Why? I find it. It's more a question of what is the definition. I think the term I'm perfectly fine with, and I would also be perfectly fine with a kind of overall objective. Yes, we want to. So the way I see artificial intelligence is really, how can we understand this abstract concept of intelligence well enough so that we can implement it into computers? So in some sense, it's about understanding the abstract concept well enough to be able to build engineering solutions which have the same kind of functionality or the capabilities. And the analogy I often use is to if you want to build flying machines, You can study birds and try to build a robot with flapping wings. I mean, it works, but it's very inefficient and difficult. Or you can study birds and learn about aerodynamics, and then you build airplanes, which of course can fly much higher, faster, more weight and more load and so on and so forth. And that's the same thing here. We study human and other types of intelligences, and then we understand what this abstract concept is, and then we build engineering solutions based on that.
So, okay, just to destruct a bit or try to understand the different terms here. I mean, intelligence, I think, is rather okay in some way, but artificial, then you can reason about in a number of ways, if that's good or not. I mean, I guess it implies some kind of synthetic kind of intelligence, or how would you interpret the term artificial in this sense?
I mean, man-made.
Man-made, synthetic, yeah. But no, okay. So
I guess the opposite would be some, I don't know, biological or natural intelligence.
Yes, and
I guess engineered intelligence would that be better?
Could be augmented intelligence. We've spoken a lot about.
But augmented, that's more the combination.
Yeah, that's.
So I think that's a different. I mean, I would argue that's a different thing. Yeah,
it's different tangent.
Agreed. Okay, so then I guess we would jump a bit more into what it actually does mean, and I think you gave an awesome,
very good definition,
analogy,
by the way,
about the birds and the plane. And we could choose to just do the flapping thing, which is, of course, the natural thing to try. But if we simply do that, then it's not that efficient. Do you think a definition saying AI should be about human intelligence is a good definition of AI?
I don't understand.
Okay, let me elaborate.
So I mean, then we say, you mean that they are the same?
Is it a good thing for the development of AI to
about replicate or mimic?
Yeah, to mimic or try to measure, compare it and benchmark it to human intelligence.
So I mean, benchmarking or comparing it to, that's what we expect. I mean, in some sense, want to be at least as good.
It's interesting at least to do
that. When it comes to mimicking, I think there is more a question. Again, I mean, the analogy, of course, showed that, I mean, yes, you can do it, but might not be the best way of doing it. And of course, the only intelligences we are aware of is our own. So, of course, copying that would still be an achievement and something worthwhile to do, but it might not be the end goal.
But I like your comment, engineered intelligence, because you can have the bird example, or you can have the washing machine example. We know how to manually wash clothes and how you do that. But when we engineer a washing machine, we understand that we don't need to have a person with arms standing there. We can do it in a different way that it's more efficient. So I think this, to me, is also understanding what is intelligence, but when we engineer it, it doesn't need to look like humans doing it. I think that's, I guess, the whole logic with is human intelligence to benchmark about human performance, yes, but one-to-one, not so sure.
And I mean, there is a big difference. I mean, there is this kind of more cognitive science, and of course, if you want to build kind of cognitive plausible models of human behavior, I mean, that's one area where you want to build computer models that behave as if they were a person with the same limitations. And the question is there it's more about understanding how the human cognition works, and maybe not kind of making it more useful from a more practical perspective.
What I'm trying to get at is what's the best way to direct research in AI? It could be that we are simply, if we are putting up a lot of benchmarks on how people play chess, how people identify images and brain tumors in CAT scans, or how they drive cars, and then we simply try to guide research and engineering in AI to be as good as possible, and compared with that's one way to do it. Another way would be to say, I don't care about how humans perform. I simply want to have something that can drive a car as safely and as quickly as possible. And that could potentially lead to another development that is different from humans. You see what I mean? Would you have a preference between the two? Do you think there is okay? If I say like this, is there a danger in comparing AIs to human performance if we guide the research in that direction? It's a very leading question, I know.
But I mean, no. I mean, actually, I would argue that I don't see the difference in some sense between the alternatives here, because I fully understand. I mean, I can understand that. I mean, how we describe what the end goal is will affect how we solve the problem.
Yes.
And I mean, that goes back to the washing machine example.
Yes, exactly.
I mean, but there I would say it's more about when we anthropomorphize too much. And when we build a robot, and then we build a robot with 2 arms and 2 legs, and then now let's build this robot to do the washing, then it may do it as people did it. And the question is that the best way of doing it? And actually, I mean, the washing machine probably is much better.
The washing machine is a robot.
Oh, well, I agree with that. So then it's more about, our conception, or I mean,
Exactly.
they're kind of more, maybe it's more about implicit implicit limitations we put on, and maybe it's also our imagination. So, but I mean, I do think it's good to have the more objectives we want to achieve,
Yes.
and then not limit that much to how we achieve these objectives. And I mean, benchmarks, depending on the benchmarks, they can be either supporting or preventing that. I mean, sometimes they're too kind of detailed, or they have a lot of implicit structure in them. Sometimes they're very open, and then you can solve it in many different ways. So I don't think the benchmarking itself is necessarily...
It's interesting for sure in any case. But let me, if I just compare it to, for example, Jan LeCun. I mean, he has said it in I think, a nice way. And the one way could be, that if you define AI as human and level intelligence, that's one benchmark, one threshold, one place to get at some point. Another could be artificial general intelligence, which is potentially different, and then you can speak about singularity, and that could be a third one potentially. But the point I think I'm trying to say here is, I think it could be potentially dangerous as well if we guide research into simulating humans. And I think we said that a number of times now already with the birds, etc., and the washing machines and whatnot. So would you, if I make a statement like this, let's see if you agree with this statement. And I'm trying to not formulate it as a leading question. It's really hard.
You are all the time now, right?
I know. But okay, simple question or statement. Of course, AI are good at some things. Humans are good at some things. They are potentially different. We can easily see the limits of the human mind when it comes to what you can focus on at the same time, and the memory abilities, etc. AI may be different there, and they may be good at other things. Shouldn't we simply focus research in AI on the things that machines are good at that potentially humans are not good at, so that they can complement each other? Wouldn't that be a better direction for research in AI?
So I think that's a good direction. I definitely agree that I think the kind of from a more pragmatic or application point of view, I definitely agree that I think our goal is to complement rather than to to replace. Yes. And I really think, I do agree, I think we are doing things differently. And I do think we are approaching, the way we solve problems, and in some sense how we solve them is very, very different. And I agree that there's a lot of complementarity. At the same time, I think there is an interest, kind of scientific interest in understanding human intelligence. Absolutely. So I think, therefore, in some sense, I can capture that in my definition, because I said we want to understand this abstract concept of intelligence well enough so that we can engineer solutions based on that concept, which in some sense, that understanding the human intelligence would be the first part. And then, yes, now we understand it. We can even replicate it, but that's not the kind of purpose. When we build the applications or try to get value out of this, then it's more, now let's engineer a solution based on our understanding how this general concept works. so that we can solve challenging problems and provide value.
So your definition gives two very clear directions of research. One is about understanding intelligence and how we can model it, and the other one is to engineer usefulness of for fundamental problems. And they are interlinked, of course, but there are two concrete directions here.
And I would argue, I mean, that has been a natural part in AI all the time. I think, I mean, you take this cognitive science, that also came out of AI. Because that was more this, let's understand the human intelligence and let's build computer models of that and kind of emulate human intelligence or aspects of human intelligence. And then that became more the cognitive science, which was more focused on understanding human intelligence. And then you had the more kind of computer science and the more technical kind of AI, which was more about the engineering part.
Yeah, and then you can take in Gulan, human-computer interaction research, right? That's kind of an interesting understanding it, engineering it, and in order to work complementary, how do we do human-computer interaction? Those are that's like clearly different directions, but they kind of need to understand each other, I guess.
And then, of course, the next level would be human-AI interaction and collaboration. And I think that's a very interesting, I mean, how do you design these systems in order to work well together with people?
And I actually meant AI-human interaction as the next level here, of course.
Because I think, in some way, there is this research field of AIAC, I mean, human-computer interaction. But in reality, what AI can do is perhaps remove that field.
Exactly, it becomes completely different. And when if we define AI-human interaction, why do you need a computer?
Should we take away Gulan's job? Is that our purpose here?
You already changed jobs.
You don't take away the job. It's simply that you don't need to have a special field focusing on building some computer interface because it will be so natural for humans, so you don't need to have a special direction.
But I would argue this is deep in his field. It's an evolution of what this field really means and what we are researching when we're taking it further. But it's still interacting with machines. But what is that interaction all about when we have AI? Maybe completely different.
But I mean, I would argue that if we see the evolution of human, interfaces,
yes.
I mean, we see that we started out that humans had to adapt very much to how the computer worked. And over time, the interface has become more and more intuitive. But I mean, in some sense, making the interface intuitive is probably much more difficult from an engineering point of view, which means that
the field is relevant.
Exactly, that it's very difficult to achieve what looks simple and easy for us to use.
Well, simply need to replicate what they did in the Space Odyssey in 2001, the HAL 9000 interface. How hard can it be?
Yeah. You have it on your computer even.
Yes,
okay, but I mean, in some sense, I think the text box that you have in like a search engine, in some sense, that's a extremely powerful and yet simple interface. You can type in whatever you like, and you get some answer. It's in some sense magic.
I don't think people understand it, or sometimes understand how much AI is actually in the Google search box and the engine underneath, of course.
But that's actually an interesting example because that used to be kind of one of the most interesting problems. Now everyone just considers it to be solved.
Yeah, yes. True. Okay, just to finish that topic, you are also. Should we go to WASP? No, let's keep WASP out of it. But if you were to choose a bit more, what kind of research a new PhD student that you supervise would focus on? What do you think the promising direction would be coming 5-10 years to do research in? And just to give some wilder thinking here.
Leading answers? Or provide some answers for me to choose from?
He wants to test his ideas, if they are valid.
Okay, please go ahead. I won't give any leading
actually,
answers.
I don't want to hear your idea. I want to hear Fredrik's ideas first.
No, but I think some of the very interesting directions today is, of course, this what we call kind of hybrid AI. How can we combine the more data-driven machine learning approaches with more knowledge-based, reasoning-based approaches? So in some sense, this kind of, more traditional AI with the more machine learning-based AI. I think that's one of the really interesting areas. And of course, there is this big debate about will neural networks under this kind of learning-based approach be sufficient? Will that be enough?
What's
or
your
do you
answer
need
to that?
I believe that you need to combine it with other things. And I mean,
and what is the ultimate utility? What are we trying to achieve here with a hybrid model? We think we get better accuracy or better usefulness?
Both. I mean, in some sense, it's about being able to solve more complex problems. And I mean, I think actually, I mean, learning is quite interesting in the sense that in some sense they can only learn what they have seen. While if you take logic, for example, it's all about deducing facts about things that you haven't seen. So, I mean, actually the power is really to be able to reason about things that you never have seen and never will be able to see. I mean, take a unicorn, for example. I mean, of course, you can draw a unicorn, so in some sense you can see it, but otherwise it's completely a construct. And you can logically construct it and logically reason about how would such an entity work and how would it react to different things, and even though it does not exist. So in some sense you cannot observe it. So you cannot learn about it just through observation. You need something else. You need to have this model, and then you need to kind of manipulate this model. Oh, we have the model of a horse, for example, and then we have models or horns, and then we can combine those things into something new, and then we can reason about that. So I really think it's extremely powerful, and it's also, I mean, actually I think it's about, maybe you can call it long distance transfer learning. And in some sense, that one of the challenges, of course, is that we learned something in one context, and now we need to change the context. And today, I mean, that's you can see that as a form of transfer learning. And today, the kind of transfer learning is only relatively small steps. And I think by adding these models and extracting this more generic knowledge from these models, and then it improves our capability to take much larger leaps and being able to transfer what we learn in one context to a completely different context, or even create a new context that didn't exist before. So I do think there's a lot of value in that. And
if we just challenge a bit, just what you said before, machine learning versus, if we call it rule-based, or if we call it...
I don't think it's versus, it's more a question of how you combine them.
Yes, okay.
I think they're different things, and they're doing different things, and then you can leverage the advantages of both.
And I think, there isn't this, I would argue that it's not a single system, that is not a hybrid system already today, but because there's always logic to any kind of system you build on top of it. And the model, even if it's a neural network, is a small component of it. Anyway, if I were to challenge that statement a bit and say that, let's say the rule now is only defined manually. So some human programmer defines the rules. And then we have the other approach, let's call it machine learning in general, just data-driven rule generation, if you call it that. So then the question becomes, what's the purpose of data-driven rule generation versus human-driven rule generation? You see what I mean?
So the question is, why are they different? Aren't most data, if not all data, human-generated? So I mean, so isn't it more a question of what kind of how that data looks like? So in some sense, you can consider, I mean, the rules would just be another form of data source. I mean, that you constructed somehow. I mean, if you read a book, if you take a textbook, of course, it would contain a lot of rules. So if the computer is able to learn by reading the textbook, of course, it will pick up those rules.
So I agree. And of course, if you have an AI system that interacts on social networks or whatnot with other humans, it's human-driven with the data that the human creates. And indirectly, that becomes data-driven. But if we still keep it to the very specific definition saying that someone defines a rule as a human, and that is hard-coded, it can't change with data. So a third definition here. Data-driven, so as the system gets new data, it will change the rules, versus the other thing, unless a human changes the rules, it will stay fixed, if we call it that. But do you see a point of having non-data-driven rule generation?
I'm not sure I follow, but I mean, I think I would switch and say that I think what's interesting is, I mean, one of the kind of properties of this more, say, reasoning-based approach is you get some form of guarantees. So if you have it purely data-driven, then you're dependent on whatever information it may get or not get. So in some sense, it's very difficult to predict how the system will work or when it will work and how it will work. So I really think what we need are some form of guarantees. And I mean, if you go back to this engineering, I mean, in some sense, usually when people say, oh, it's been engineered, it means that you know it will, under certain circumstances, actually work. And I mean, we know the bridge will manage this amount of weight and it will last this long and so on. We know some things about the bridge. And I really think that's what we're missing from at least the machine learning part. It's that it's very difficult to predict what, I mean, if I want to reach a certain accuracy, how much data do I need? Okay, I got this accuracy now. What do I need to add in order to achieve this accuracy? And under what circumstances will it work, and under what circumstances will it not work, and so on. So I think it's very much about having more, being able to formally analyze and prove properties, or at least have some form of formal understanding of the system. And that's what we want to achieve, rather than having fixed rules. And I mean, in some sense, I think that's one of the weaknesses, of course. I mean, and in some sense, this, kind of crisp Boolean boundaries, of course, that's extremely challenging.
Yes.
But then you can argue, so I mean, I think that's one of the weaknesses of these, but that's more on the kind of symbolic and logical representation point of view. But if you take the other perspective of the more data-driven, I mean, for example, taking this of you learn to predict how a movie sequence will continue. And I mean, in a movie you have objects. And I mean, if you're holding a glass or something, you need to do something with it. I mean, it's not like it's going to. I mean, it's kind of a something that will either you would put it down, you will throw it away, or I mean, you cannot just blur it, because I mean, usually this kind of this averaging out things.
Discrete object in some way you need to reason about in some way.
And I think this discreteness is what's one of the things that are missing there.
I think I'll add that to the list in a more societal kind of end of topic kind of things, because I love to get more into depth about the thinking about symbolic AI and what that really is, and But okay, so last point.
So I think, well, I mean, there was one thing, and I think a second thing is really, how do we go from today's mostly correlation-based method to more causality-based methods?
Right.
So we really need this kind of direction to the how things influence each other. And I think this also goes very much into how do we combine the more kind of analyzing data we get with the more active action part, so that we actually can act on the data and do something in order to change the world in our liking.
So having an interactive part of the learning process in some way.
Yeah. But also this, that, I mean, if you just have a purely data-driven method, usually it's very difficult, if not impossible, to get the kind of causal structure in order to find...
I love to...
that you cannot discover the causal structure just by observation unless you have some active intervention. You need the active intervention in order to be able to determine or to, differentiate between different kind of causal directions.
Yes. It's like an A/B test. I mean, you can have whatever data you want. You will only find correlations in it until you actually perform some kind of tests in it. And that, I guess, is what you're meaning with some kind of active intervention.
Yes.
Okay, so trying to find some kind of summary of this topic of, how should we direct research in AI? And you've spoken about a number of things, like hybrid AI. I guess what the other part would be conformal AI, I guess, also having some kind of understanding of the boundaries or the limits of it. Or how would you phrase that field of research?
I mean, for me, it's more the kind of theoretical foundations.
And then we have the symbolic part as well, causality-based. And Yeah. Okay. So that are a number of.
Yeah, those are some. But I also think, I think this is very interesting. The kind of role of scale. I mean, if you look, what is the role of scale?
Yes.
And
I guess
how
you mean
important
scaling of data and model size.
Yeah, exactly. And I do think there is something about scale that changes things.
Something magical happens when you scale stuff.
Yeah, but also that different, things that are, they get different problems or different challenges when they are working with scale. And that also works with, just human organizations I actually think one interesting example of that is, I listened quite a long time ago to a talk by people from Axis, this camera developer in Lund. They got the question of, why don't you have more automated functionality in your cameras? And then they said, well, we have installed 100,000 cameras in the London subway. If we, then it was like, if we're going to have this automatic detection of people on the tracks, even if we have like 99.99% accuracy, it still will generate 1,000 errors, false alarms, if say every hour or something. Yeah. So just if you have 100,000 cameras, the kind of accuracy you need to be able to use an automated system is just insane.
But the alternative to do it manually is even worse, right?
Yeah. But that's a good point. But it's also that it's. So the question then becomes: is it easier to detect manually the kind of positive cases, or detect the false negatives? But yes, I agree with you that probably this would be a part of the solution. That yes, probably easier to look at those 1,000 sequences rather than to look at 100,000 sequences.
Exactly. Awesome. Time is flying by. With so many topics here. So
one, if I'm simplistic here, like one area I picked up on, I don't know if you covered it, but how do we? What about research around unsupervised versus annotated supervised learning? Like, in order to scale this and become better, we need the systems to become better dealing with unsupervised. So, like with less data, be able to do stuff. Is that valid? No,
but that definitely. Actually. You mentioned WASP, and actually one of the areas we pointed out there was this: how do we kind of make reduce the need for data? So in some sense, increasing the data efficiency. And then, of course, today, is there a lot of interest in this semi-supervised learning, and I think these diffusion models and so on are very interesting, where you basically generate your own training data. That you start with something that you know what it is, and then you add noise, and then you get something that's less and less recognizable, and then you learn how to reverse this process. So in some sense, you're messing things up, and then learn how to fix it, and then through that process, you learn how to recognize things and kind of from a more messy.
It's another synthetic data method, right?
In some sense. So I do think. We also have these autoencoders and so on, which I think is also very interesting. So in some sense, how can we? It doesn't matter what the input is. We just know that the input and output should be same. We have absolutely no clue what it is. But then I think what's missing there is really the correlation with the external world. And I think that's the thing. It's the system can build up its own kind of internal representation, and this internal representation might be coherent and consistent. But if you cannot communicate with the outside world, if you're just making up your own words, your language might be completely kind of grammatically correct and coherent and everything, but no one else understands it. So you need to build bridges between your internal representation and the external world. So in some sense, the external world is what we share. And by learning from the external world, then we can start sharing our experiences and actually talk to each other. And then I guess we can connect this back to the wine tasting example I used in the beginning, that what we did, we had maybe our internal representation of these smells and tastes and so on, but we couldn't make them explicit, and therefore we couldn't discuss them with others. But then by jointly converging on a common vocabulary, then we could start discussing it. And I mean, there are experiments like Lux Steels and Sony Labs in Paris. They did this where they basically have two robots communicating with each other about shared objects. They build up a joint vocabulary how to talk about these things without having any predefined notion of vocabulary.
In interest of time, and I know you have to leave sharply at like 7 o'clock or shortly after, could we go through a number of topics just to make sure we capture the most important one and try to keep the answers as short as we can? And that's
yes.
a lot of things. I mean, you have such an interesting background, and just to.
I was thinking we can make like a short clips of 12 minutes, so somebody measures the time.
12. I think 12 minutes is too long, but
we will get into the speed dating part here, or speed questioning.
Okay.
I will keep the time on 10 minutes max.
Let's go for, should we take H-leg or WASP? Should we do WASP, Fred? How did your interest and contribution to WASP start? And perhaps you can start with WASP. What is WASP?
Maybe that's a good start, yeah. So WASP is the Wallenberg AI Autonomous Systems and Software Program, which is Sweden's largest research program. And it's mostly funded by the Wallenberg Foundations, but also with significant co-funding, both from the universities and from companies. And the overall objective of WASP is really to do the basic research now in order for Swedish industry to be competitive in the future. So the kind of starting point is really this, that there's a lot of things happening in the world. Swedish industry really need the competence and knowledge in order to stay, because I mean, we're a very export dependent country. And of course, that means that we're very dependent on being competitive on a global scale. So that was the starting point. And I have been involved in the program actually since writing the applications. I was part of writing the application.
The initial ones?
Yeah, exactly.
What year was that?
2016, 15, 16.
Okay.
This is behind the scenes before it was formed.
Yes, I think we started fall 2015, and then it was submitted like early 2016, and I think the decision was in May 2016, and then we started in September 2016 getting started. So I was responsible for writing the chapter about, or the part about the graduate school, and then it was kind of natural that I got the offer to be the director of the graduate school. So we built it up from the start, and with other people, of course. And I mean, today we have 360 PhD students in the program. So the overall goal, the kind of numeric goals, is that we should educate at least 600 PhDs in the areas of AI, autonomous systems, and software. And I think at least 150 might have increased. It seems the numbers always increase of industrial PhD students as well.
Right. Yeah, that was my question I was having on my tongue. So to create a WASP graduate school, how does that relate to the normal university academia system, or what is it a new school, or is it more for focus on industrial PhDs, or? No.
I mean, so basically it's added value on top of your local PhD program. So every student in WASP is enrolled in their local PhD program. So I mean, you're accepted to Linköping University, then you need to follow the Linköping University rules. So this is add-on. So it's really about adding added value. So it's about creating new courses. We have developed a large number of new courses that didn't exist before. We are organizing international study visits. So I took all the 65 students we had in the beginning to Zurich and Munich, and then we took all of them to California. And I mean, it's kind of interesting to take 65 people to go on a trip like that. Yeah. So it's really about building an industrial, academic, international network. So it's very much about networking as well. Besides, of course, the knowledge content as well.
So step one, you enroll in a PhD in one of the associated universities, and then add on, you can be part of this graduate.
So, there are two ways to becoming join the graduate school. One is to have your position funded by WASP. So all the WASP-funded students, of course, are part of the graduate school. And then we have an affiliation program. So if you have your funding from another source, you can apply to be an affiliated WASP PhD student, and then again, you're part of the program as anyone else.
And you highlighted 150 industrial PhDs. What's the distinction here? What is that?
An industrial PhD student is a person employed by industry but doing a PhD at the university.
Yep. And
So
how do you do that? How do you get? Is that through the? How do you get that if you are interested in joining like that?
So, I mean, WASP has yearly calls. So usually in the spring, if you're a company and you have some employee that you want, I think you would be a suitable PhD candidate, then you can apply for this to get funding to cover part of the salary and to cover the kind of cost for the university for supervision and so on. So that's usually a yearly call on industrial PhD students in the spring, and the call for affiliated students is usually in the fall. So actually we are just evaluated this year's applications. And then there's also the academic PhD student program, and usually there's also a call about that in the spring.
Okay.
And it's a really great, or one of the best way, I would argue, for PhD students to actually, and also for industries to get money for it, because you cover quite a lot of the expenses and you don't have to pay as much as you would for other type of industrial PhD programs, at least. So it's really good, I think, or the best and the biggest, so to speak, of the graduate school programs in Sweden, at least, right?
Yes.
Saying very non-biased way. Right? No, but I truly, I mean...
But I think if you look at numbers, I think there's nothing close.
Yeah.
I mean, the total funding is, what is it? 5? Is it maybe 6 billion now?
5.5 or something.
Yeah, exactly. I mean, it's growing all the time. So, I mean, there's at least 5 billion Swedish kroners in this program, and it's also a 15-year program. So I think, I mean, I really think what's the kind of unique part here is really, again, it's scale and it's volume, both in the kind of numbers. I mean, we normally have about 40 to 60 students every year. And also that it's going on for at least, it started out to being a 10-year, now it's been extended to 15-year program. So it's also really about long term. And I think here is a challenge with many of the other kind of funding sources is that either it's not enough, I mean, it's relatively small grants, but more problematically is usually short-term grants. And I really think knowing that, yes, there will be a call next year and so on, that really makes a big difference.
And trying to keep the answers short here, perhaps we can jump to at least a related topic. Why should someone consider taking a PhD, potentially from WASP? What's your answer to that?
But I mean, really think, I mean, the amount of knowledge and the kind of, I would say, I mean, first of all, of course, it's fun and interesting in itself, but I also think that the types of jobs that you can get is also more interesting and more challenging. So if you're really interested in being at the cutting edge of not only, I mean, it's not today's technology, but actually tomorrow's technology. And if you want to develop the technology of tomorrow, I think that is extremely valuable. And it's also the case if you want to have an international career, having a PhD is a huge advantage.
Even bigger abroad, right? Than
Yes.
Sweden?
Yeah, I think probably more abroad than Sweden, yes.
And
So that's a pretty strong value proposition. Work with the coolest kit and have the biggest, coolest network.
Yes.
Two very strong points.
And I'm trying...
But I mean, I definitely think this the biggest value from WASP, I mean, for the WASP PhD students, I really think is the network.
Yeah.
And I mean that the people that they work with, both kind of academically, but also their peers, I mean, the other students, will most likely be the leaders of Swedish industry and Swedish research for the next 30, 40 years.
And just we have to have some Elon Musk quotes and citations here as well, for every podcast. But, he started a PhD program, but he quit and chose to just focus on his own companies, so to speak. Oh, how should I phrase this question? But you can see if you're... I don't want to phrase it like that. There are different ways to make you be able to work with what you're interested in. That could be motivations such as economical motivations. It could be motivations such as being able to build up your expertise and be proud of who that was leading. there are different motivations for how you proceed to educate yourself, so to speak. Because do you consider as well that PhD studies is basically a study program that enables you to be a scientist?
Yeah, I mean, I agree. And I mean, in some sense, you could put it this way. You get salary for 5 years to do the things that you find is the most fun. So in some sense, either you have to build a company and raise all the funding yourself, or you get a paid position to do it without having to worry about the financials.
Well said, well said. I mean, do you see the trend going up and down, by the way, in number of PhD students applying for programs in Sweden?
I mean, I would say that before WASP, or at least maybe outside WASP, I mean, the number of international students is huge and compared to a number of Swedish applicants. But for WASP, we actually get a lot of Swedish applicants as well. So I think it has a stronger brand and considered to be more valuable for Swedish students.
Yes.
And I think that's a difference.
Awesome. Let's move to another topic, if that's okay. And I'd love to hear more about how you got started in the EU high-level expert group. Can you just speak a bit about the story behind that, how you got started into that or connected to that, and what you started working with?
So actually, I mean, that was an application procedure, and I was asked by the Swedish government to apply, and I did, and I got the position.
And what is the position?
I mean, not position, but I mean that. So I mean, there was 55 experts from different countries that was selected to be part of this high-level expert group on AI.
With the objective of?
So I mean, the objectives were basically, so I mean, when we started, there were two objectives. One was to develop these guidelines, ethical guidelines for, I don't remember if there was trustworthy AI from the start. Probably it was from the start. I mean, it was developing these ethical guidelines for trustworthy AI, which we did. And the second was to develop policy recommendations, investment and policy recommendations for the Commission and the member states. So those were the two reports that we were kind of commissioned to develop. And of course, the ethical guidelines probably is the ones that is most well known and I think has had a huge impact and is being built on by most people. But we also had these policy recommendations, which I think was unfortunately didn't get the same kind of impact, at least not explicitly.
That maybe is more important or equally important.
Yes. So there I was responsible for writing the part on world-class research. How should Europe take a leading position there? And I was also very much involved in the education section there.
Can we? What's the elevator pitch on your argument or your recommendations? That's on education.
I mean, well, education. I mean, actually, I think education is interesting in the sense that. What we see is that the amount of knowledge grows exponentially, and our education system is fixed length, which of course is a very bad combination, which means that our education systems cover less and less of all the knowledge that exists. And it also means that we need to learn significantly much more after we finish our kind of formal education as we do during our education. So this kind of old kind of view that, yes, you do your education and then you're kind of done with that and now you work. I think that is completely, obsolete.
It's obsolete.
Yeah.
But let's try to keep the topic here.
Okay. So, but I mean, I really think it's about
the topic in its own, actually.
Yes.
So the H-leg, so to speak, can you just speak a bit about how was that working in EU like this and actually developing the ethical guidelines is an interesting topic in itself. Can you just speak about how did it work? What do you actually do? How do you collaborate? How do you come up with some kind of consensus on what the guidelines should be?
Put it this way, I now have a much bigger understanding of how things in the UN and so on works. But but it's kind of interesting in the sense that, it was very intensive work. So actually, most of the work was done in actually less than a year.
Do you travel there physically?
Yeah, we had 2 meetings every month in Brussels. Yeah. So I was traveling to Brussels twice a month. And it was basically that during the meetings, this was about actually reaching this kind of consensus and then assigning kind of writing tasks in between. And then in between these 2 weeks, you had to do the writing. And then there was a new draft that you discussed the next time. And basically it started out more kind of dividing it into different sections. But relatively soon everyone realized that this is not a document which you can kind of break down into section and write each section independently. You really need to consider it as a uniform, and then it kind of became, well, you start at page 1, now let's discuss. So and as soon you just go through the text, and whenever someone has an objection, they raise their hand, and then they discuss, and then you iterate over the document.
Iterative process over the whole document.
Yes, more or less.
Did you have some specific role of that process? Did you have some specific expertise area, so to speak, that you focused on?
I mean, it was an interesting mix of people, and I mean, I was more in the kind of, technical expert kind of background.
It's a very diverse group. These 55 people, very diverse.
Yes.
Maybe that's a good thing.
And actually, I think in some sense, I think that's a challenge in the sense that it was very clear that people had a very different kind of prototypical example in mind when they talk about this.
Exactly.
And I think, if you came from a big industry, of course, all you think about, here are my machines or my products, and how they share data and so on. And that's a completely different compared to those that kind of maybe had a less technical background and thought, it's kind of more Facebook or Twitter and so on, and those kind of consumer products and interacting with people and so on. So I think that was the lack of a shared
We're getting back to the wine tasting problem.
Yes, exactly. Yeah.
It's actually quite interesting how important a common vocabulary becomes when reasoning around stuff like this. And that obviously then is a huge challenge when you have a very diverse group. And you want the diverse group to have all the different perspectives, of course, but then you need a shaping time of the semantics of this group. I don't know. It just feels really difficult before that happens.
And I think the most difficult part was trying to agree on a definition of AI.
I was coming to
and
that.
And that I think in the end, we just gave up.
I think
actually we wrote a large document, but
I think you actually did come up with a surprisingly good definition in that time. And I'm having as the next topic the AI Act, so I would love to hear your comments about their definition as well. But can you just speak a bit about the work to come up with a definition? I guess you were part of that to a large extent as well, or?
How did you go about getting to the definition? It's quite interesting.
Yeah, well, that was complicated.
Blood, sweat, and tears.
Yeah, but I think that's when you really becomes very explicit that people have different perspectives, because of course everyone could come up with their own definition from their perspective. But how do you merge these? And in some sense, what happened was to add and this and this and that, or that and that, and then
dilute it,
and then it becomes extremely complicated. So I think the challenge is how do you make it both kind of concise and still meaningful.
Do you remember the definition from the guidelines? I can look it up if you don't remember it.
I do think it's artificial intelligence refers to systems that exhibit intelligent behavior by analyzing the environment and acting with some degree of autonomy based on designs or the kind of goals given by the designer.
Yeah, I like that. And if we could,
I actually think it's not too bad.
No, I think it's pretty good. That was the starting point, and then, as I said, we had this document which is many more words.
And sorry for jumping quickly here, but the time, I know you have a time limit, so I'd like to cover some of the more interesting topics here as well. And one of them, which is really interesting, I think, is the upcoming EU AI Act. And have you been involved with that, by the way? I guess you have in a number of ways. Or?
Yeah, yes, some ways, yes.
Would you give? How should we start this topic? Let's start like this. Do you think? Why is there a need for a specific legislation on AI compared to having legislations that we already have?
That's a very good question, and in some sense, I'm not sure whether that has really been adequately addressed. And actually, that was one of the things that we in the high-level group asked for, is that is there a legal analysis of what the kind of gaps or the kind of missing legislation is? And as far as I know, I have never seen such. Because, of course, it's not the case that there is no legislation. I mean, all existing legislation still applies.
Yes,
Exactly.
So the question is, of course, what is the kind of specific nature of these systems which makes them relevant for this kind of legislation? And I would say the main argument for it is probably the impact. And since the AI Act is taking this risk-based approach, that if you have systems or applications which has a high potential impact, then of course the regulation should be equally tough on it.
Severe or
Exactly. I failed to find the word, but and I mean, in some sense, I think that's a reasonable approach. That of course, yes, we want. In some sense, with great power comes great responsibility. So I mean,
Spider-Man.
that's very much aligned with that.
But
speaking about the risk-based approach, so basically it means that if there is low risk, it's basically no regulation, or if there is high risk or even unacceptable risk, it's even forbidden in some way. Any thoughts about taking that approach? Do you think it's good or bad?
So I mean, I think the intention is good. I think the practical part will be very difficult. So my prediction there, and I think that's also in our official answer in response to this, was that, or is that, I think most applications will be considered high risk. And I think there is a lot of kind of incentives from if you take the developer perspective, since you as a developer don't know exactly where your customers will use the software. I mean, you can take something harmless. I mean, I don't know, you have a scheduling software that you do for scheduling machines or something, and then suddenly someone uses this to schedule, I don't know, operations in a hospital or something. And now, did it become high risk now? It's not clear, I mean, whether that's considered high risk or not, but it's more in healthcare, and of course, healthcare is more sensitive. So I think from a developer point of view, you probably cannot really afford to take the risk of assuming that will be just low risk, and then it might be turn out to be high risk. So I think from a developer point of view, you will prefer to see the high risk. And then, of course, for the consumer perspective, it's the same thing. You might not be sure. We're not completely sure, so let's be on the safe side. So let's just assume that it's high risk, and then we're on the safe side. So this kind of expectation from the Commission that we have this kind of pyramid where there will be really, really few unacceptable risks and like a small number of high risks, and then most applications will be low risk.
It won't play out like
I
that.
think it might not even be the opposite. Yeah. So that's something I think it's like the consequence.
But the problem, the real issue, I think we learned a little bit from GDPR, is to go from intention to execution, right? And how in practice will we approach this as companies? And I think here, I wish and hope we can learn from what we did and what we didn't do, and basically, if you have an AI Act or GDPR Act, I argue there is the core policy, but there needs to be a meta product. There needs to be a lot more around this in order to have less friction or headaches on how to interpret it. And only relying on case law that doesn't exist, it's a real vacuum for a while. So I want to elaborate a little bit, like what are the things around an act like this that really needs to be there in order to support us to use it properly? I think this is a hard question. Right?
And I mean, I think this is a very valid question. And again, that's one of the things that has been, I mean, I among others have raised, and that is the purpose of the legislation is to increase the legal certainty. I mean, again, that's one of the purposes, that the intention is that companies should know that in some sense, this is the legislation. You cannot, I mean, you don't have to expect that there will be something completely different 5 years from now. So you know what will be the case.
It's there to give clarity.
Yes.
That's the objective, right?
But then I think you have this issue that, first of all, you have the member states that are supposed to implement this. And we know that different member states implement it differently. And then secondly, you have that, yes, now there is overruling, and then it goes to European court. And of course, that takes a lot of time. So in some sense, the question is how certain is this legal landscape before everything has been through the courts a number of times. So actually I've used this comparison to the kind of quantum state. So you have this quantum state of the law. So the law is in all possible states until it collapses when the courts have actually decided at some point.
Oh, I'm going to steal this.
Yeah,
the quantum mechanics of EU law.
Or of the AI Act. It should be another.
But it's not
t-shirt,
about
I think.
only AI Act. It's generic about
No, but
the way the law works.
The way the law works
Yes.
is quantum mechanics.
Yes. So anyway, so I think that's, and then of course the question, what is the other things? And there it's very clear that from an industry perspective, they want to see standardization. So there's a lot of work on standardizations these days, both on European level and also international level, on agreeing upon standards. And I mean, actually, there was another, if you say the kind of differences in this high-level group, then where industry was very much pushing for standardization as a way of agreeing upon this is the best practices. This is, if we do this, this is good. I mean, it's a good enough. And then it was very clear that, for example, consumer organizations did not accept this. That you should not be able to hide behind a standard. If there is if there are kind of damages, you have to face the damages. In some sense, you have to own the problem, even if you follow all the best practices. If it goes wrong, it's still wrong.
But I can see the pragmatism of industry to trying to navigate the landscape, and then standards or best practices that we did according to book, and we came up with this. Please help us now. And so I can follow both arguments, but the practicality of executing needs standards or something to hold, some guidelines.
Yes, and then of course we have the big challenge that in some sense I would argue that the scientific foundations are not really there. I mean, there's still a lot of unknowns. So I'm leading one of the European AI Research Excellence Center networks, TAILOR, where we are developing the scientific foundations for trustworthy AI. Yeah. So I think there's still a lot of research to be done before we can realize this European vision.
And give a snapshot. What is the scientific foundation for trustworthy AI explicitly?
So I mean, for example, we are developing kind of more technical solutions. So we take the standpoint that we need to be able to integrate techniques coming from learning, optimization, and reasoning. So that we need these kind of guarantees, but we also want this data-driven. For example, we are working on different metrics. How do you measure trustworthiness? How do you develop models that are both kind of learning from data, but still having these guarantees? So these neurosymbolic approaches and so on. And we're also working with auto AI. So basically, how can we automate a lot of the manual process work needed to set up the pipelines and do all the manual configuration of our learning systems, which is actually very error prone and very difficult, so that again we can make the systems more trustworthy by automating a lot of the practical details around it.
But I don't know if you want to go here, but this is a really interesting rabbit hole with both techniques for trustworthy AI and transparent AI, and we've been onto this topic explainable AI. So basically, there are techniques and technologies and way approaches how we can ask the model to explain itself, and those kind of techniques would vastly simplify and understand this landscape versus, trying to do it with a questionnaire, like an analog approach to this is not sufficient. This is a highly digital approach.
Yeah, I mean, I think actually one of the interesting statements we made in this guidelines is also that kind of verifying the quality and the kind of following of these guidelines is not something you can do once. Again, this kind of goes against what the industry wants. They want to have, let's stamp it, now it's approved, now ship it. And that I don't think works here. No. And it's really a continuous process that you need to do throughout the full lifetime of the product.
But let's see if you agree with my core hypothesis here. If you want to have an AI Act executed upon, this is not. We cannot solve this with analog practices and methods. We need to have highly data-driven methods of, however we want to control this or supervise this or monitor this or whatever. I paint the picture. I have a new AI model, and now I want to certify it. So I want to have a certification engine, not a certification analog document questionnaire. Do you see the difference? So there's high-level technology involved in here in order to certify my product. Something like this is in my mindset. Do you understand what I'm going for?
And actually, we have been doing work on what we call execution monitoring, but in some sense it's a form of runtime verification.
Yeah.
So traditionally you verify your software in advance, and then you verify a model of your software, not your real software.
Now we're talking.
And what we were doing was actually verifying the execution of your software, but using the same kind of formal methods for expressing your safety constraints and so on. But instead of verifying the model, we're verifying the actual execution. And then you actually gain also computational efficiency, because you don't need to verify every possible execution of the system, but only the kind of particular execution of the system. And then we can also extend it. So the challenge, of course, is that if you're just doing runtime verification, you just verify that, or you can detect that it did something unwanted. So what we did was also extend it to take predictions into account. So we could say that if you don't change the behavior, if you continue on this kind of trajectory, you will violate these conditions in the future. So then you could take action before it actually violated any constraints.
We also try to end this discussion somehow, but I think we need to speak about one of the more controversial topics in the AI Act, which is the definition of AI, of course. And then compare it to H-leg. Actually, my recommendation as well, when giving my or our thoughts about this, is to actually use the H-leg definition of AI, which I think is much better than what was proposed here. It has changed over the time, though. What's your thinking about the work and the definitions of AI in the AI Act?
So, in some sense, I think I have a very pragmatic view on AI definitions. I just reconcile with the view that there are so many different definitions, and I think every definition has some merit. Yeah. And of course, there's also weaknesses with the definitions. And I actually think, to me, it just shows that AI is a very multifaceted and actually very complex topic, in the sense that you cannot capture it easily in a single definition. And then, of course, the lawyers don't like that argument. So I think then we come back to this legal certainty. And in some sense, they try to define it more around what kind of technology is being used. So in some sense, I'm perfectly fine with that. I think that's a reasonable way of doing it as well. I think to me, at least, the challenging part was, they used basically three components, that either would say a logic-based approach, or it was a learning-based approach, or it was some kind of optimization and statistical approach.
I think they
I think
they covered all software in the world.
Exactly, and of course,
they have just covered every single software in the world with that definition.
I agree with that, and then they could just written that every software, then we'd be done.
Exactly.
So actually talked to lawyers about this, and at least one of them argued that no, she had a very strong opinion about no, it's not about. So yes, it covers everything, but then there are other requirements. So I think this might be one of those cases where we, as kind of more technology-oriented people, don't understand how these definitions are interpreted from a legal perspective.
True.
I'm glad that you've taken up a more optimistic view on the definition. And I think you're right. We shouldn't simply squabble or think about that too much. I guess having more example-driven definition could potentially be better, which some argue that they do in the risk-based kind of definition. So
I would argue, to me, the really difficult part is really that there needs to be a certain level of abstraction. It is classical. Is a thermostat an intelligent agent or not?
Yes.
And I think most people agree that a thermostat is not intelligent either. But you could make an intelligent thermostat if you start thinking, it predicts that, I know that there are 4 people living in this place, and I know that you should come home this time, so therefore I start heating up or cooling it down. And then suddenly it takes a lot of other things into consideration, and then suddenly it becomes extremely kind of complex and potentially intelligent.
Are you optimistic in how the implementation of AI Act will have, or what the effects of that implementation will be once it's actually enacted and in use? Do you think it will hamper innovation? do you think it will actually bring Europe to a leading stance in having more trustworthy AI, or what's your thinking once the AI Act will be deployed, so to speak?
So I would argue that if Europe invests as much in innovation and research and innovation as they invest in regulation, yes. But if they fail to do the comparable investment in the research and innovation, then it might be problematic.
I want to put it's half a joke. I wish, in contrast to GDPR, that the AI Act will spur a huge boom for startups to put together data and AI monitoring certification technology rather than driving analog lawyers' bills. That would be cool.
And I mean, of course, that is one of the fears. That again, it will favor the incumbents and will favor the really large companies that can afford to have a huge number of lawyers employed. And I really think that is the real challenge here. That how do we support more the startup companies? Because from what I understand, one of the challenges with GDPR is really this, that one problem from a large company perspective is that if they buy a service or a component from a smaller company, they are responsible, which means that they don't afford to take the risk because they can be fined, 4% or 6% of their...
So you're really pushing in that the startup or the mid-sized company even working with the large incumbents will possibly be outcompeted on these topics.
Yeah, the problem is that the big companies don't dare to use components from the smaller companies because they will be liable.
Yeah, probably.
And that is, of course, the challenge here.
But I think one of the conversations we've had many times here on the podcast has been about this part of the AI divide here is that for the tech giants, they had the smoothest ride to comply with GDPR because they had the technical infrastructure to easily pick out the data they needed, and they had the lawyering muscle. So they had like the trifecta of understanding the problem, having the technology infrastructure, and having the lawyering. So we wanted the GDPR was to protect us to some degree from the, if I'm cynical, from the tech giants, and they were the most favored by the act. Is my argument. That's quite. I don't want to do that mistake again. Do you agree, or do you think I'm way off? I'm a little bit pushing.
I don't argue against you.
I have a very practical question, actually. When do you think that the act will come in place? And will it come in place?
Mm-hmm.
So, I mean, the latest news I heard is that things are being pushed through, and it may very well be that the act will be decided when Sweden will be in the president of EU next year.
So, that was...
So 2024, beginning something.
23.
So yes, so I mean, so far as I mean, I think the trilogue
as well. I mean, do you think really that will happen in less than 1 year? It still have to pass the parliament, right?
So the thing is that things are being pushed by the Czech presidency, and I mean it's been discussed quite a long time and so on. So it might very well be that they might be able to push it through.
And how long will companies have time to comply with that? Is it going to be like GDPR when they had got like a 1 year or 2 year to comply with everything? Or
I actually don't know what the timeline is after it has been. I mean, how long it will take to be ratified, because what it means is that then every member state have to change their laws and so on. So I assume that there will be some time even after the Commission makes the decision.
And how much can you give us a view at, like, in terms of monitoring and controls in each country? How ready do the country needs to be to act on this when the law passes?
I mean, again, I think this is one of the really, to me, the weaknesses. And I mean, again, it could be a really huge problem. And that is that each member state is supposed to have an expert authority. And what's interesting is also that they explicitly said that this expert authority should be able to give advice. And in Sweden, that's completely against the way that it works, that we don't give advice. You send in your application and we say yes or no.
Exactly.
And now they're supposed to help and guide companies and organizations to comply. And I think that would be a very, very big step for kind of a Swedish agency culture.
But we have agencies in Sweden that are better at this, like Finansinspektionen has gone more towards a guiding, advising role than pure send it in and we apply it. Because I think this is really what is needed.
I agree. And I mean, I think if you also have this dialogue, then of course you hopefully can reach reasonable agreements. But again, I think that goes very much against
normal
and the way that, and I actually think Sweden might be one of those countries where a lot of these things will be more difficult. Oof. Because that we have this kind of culture that, well, you should not be able to have a dialogue because that's unfair.
Okay, so it's the clock is running, and I love to move to another topic, which is something
we're done with this. I can't take it anymore.
That was born in Linköping as well, and I think you know what I will be heading towards. Something in Berzelius. I guess you can guess what I'm speaking about. So they're building a large language model for Swedish, also in the big Wallenberg financed cluster in Linköping called Berzelius, GPT SV3, so to speak. What do you think about that? Any thoughts about pros and cons of building a Swedish large language model?
No, I think that's a very good thing. And I mean, I think it's one of those challenges where, of course, the big languages will be taken care of by others. But if you have smaller languages, no one really cares that much. So one has to do it oneself. And I really think this is a great initiative. And I'm not involved at all, I should say.
Okay. Okay, so can you think about, there are many ways to build models, and I'm trying to not phrase it as a leading question here. It's really hard. But you could also argue that these, okay, let's move it to generative AI in general. We've seen an explosion in number of generative models. Of course, language models was the first one that really came about, being able to generate text in different ways. Now we see it for images and audio and everything. Do you think these kind of GPT-style models, which can move towards more general AI, like they can basically do few-shot learning and you can ask them something and they can answer something, is something that's obviously interesting from a research point of view. I think everyone agrees, and it's really fascinating how we can start to move towards these more general type of AIs. Do you think they are also of practical use for companies short term to have a large language model that they can use for, let's say, Clas Ohlson or whatever company that wants to use AI?
Yes.
Okay, why is that? If you take some example, can you give an example of what they should use GPT for in some retailer or some other company you would think of?
I mean, actually, I think these generative models are probably much closer to the way we actually work than we wish or we like to admit. And I really think, the more I think about it, the more I mean, isn't that how we work? I mean, you gave me a prompt, I generate an answer. Based on my answer, you generate a new prompt and so on. And then we just go back and forth. So I really think these kind of generative models are probably extremely generic and probably can be used for more or less anything. And I mean, we see people starting to use it for, generating text, of course, but say generating tests for working in school or generating instructions or so I really think there are the limits will be more in our creative use of this technology than in the technology itself. And I think the really hard part is how do we now? Of course there will be limitations, especially when it comes to more factual questions or more kind of reasoning. We know math, for example, is one of those things that they usually have a trouble with. how do you steer the training of these to solve particular challenges or weaknesses that you find? So what I expect is more that you use this to generate the first version, and then you kind of manually edit it. So and I saw a graphical artist that was using more this image generator and said that, well, it saved me 80% of the time because they could generate the kind of initial idea. And I got like the rough first version, and then I just manually did the polishing and generating the nice things, and then I'm just done.
Do you see any practical issues with having a large language models of like GPT style, where we had 175 billion parameters in it for normal size companies? Okay, let me be more concrete.
Yeah,
okay.
I think
if we take an example, let's say they want to classify something for customer support. Let's say they want to build a recommender system. Let's say that they want to do some sentiment analysis or something like that. And they have their own data, they have their own categories potentially. And how should they be able to potentially fine-tune a system on their own data? How should they be able to send the data to the system, because they can't even host a model like this themselves? They have to send it through some API in that case, and that means sending potentially sensitive data they have through some kind of trusted partner that they have. Do you see any issues with these kind of things?
I think that was an extremely leading question. So
I
it seems
know.
like you. So it
I
seems
was
like you.
biting my tongue here.
So it seems like you have a lot of objections. I mean, I'm not really working with these systems myself, so I cannot talk really about these pragmatic issues that you bring forward. But I mean, if you take a more, I think of course there's always this challenge. I mean, definitely when it comes to the size. I mean, you said that you're dependent on external services.
Yes.
And of course, that might be a limiting factor. Also, I mean, that depends also how you can build upon it. I mean, can you actually get something that you can then, as you said, adding another layer on top of it that I can train with your own data? Or is it just you send in the prompt and you get it back and then you cannot really use it more explicit? Or I mean, more,
With my non-technical know-how at all here, I'm now parroting. But I think what we're talking about here is the ultimate. If you go to the Googles and the Metas, and we talk about foundation models, it's very, very large, big models that someone is serving. They are, or maybe now here a Swedish language model, and then basically how to interact with foundation models or how to use that to then do something that is in your operational, pragmatical own system. So I think the challenge here, the way I understand it, is that if we don't have a strategy in technology setup, what is the foundation model and how do you bring from foundation model to your hardcore use case application, then I'm kind of completely in your corner, Anders, that sort of, how can I build a practical use case with a foundation model over here that sort of serves my daily?
The thing is, for most tasks, I would argue, you can get so much better performance accuracy-wise if you train it on your own data and with a smaller model as well. That said...
A narrow model. We're talking very specific.
Yes, very narrow ones.
Yeah.
That said, of course, it's super interesting from a research point of view. No question about it. It's one of the most promising and extremely surprising, I would say, with the scaling laws that we're seeing, that it actually does work, and it's super cool. But I think people are fooling themselves if they think they will have practical use for it in coming years.
But now let me argue against you, because obviously there's very large players who are putting an obscene amount of money on the play of foundation models. So clearly they have understood that we think there is an opportunity here to have foundation models that very few in the world can do. And of course that will bring value, but then they need to understand how to monetize that. And your argument is almost like, well, we don't need foundation models at all because we can all do the narrow stuff.
No, I never said that.
No?
So don't put words in my mouth.
Good.
Of course. Please don't. No, I think, the time is actually getting close to 7 o'clock here, so we need to finish off. That said, I just want to summarize, and please let me know what you think about that. I mean, for one, as I said, research-wise, this is the most promising and exciting fields of research that we're doing. I think startups that are trying to find business models that builds on top of foundational models will have an extreme success in coming years. What I don't think is that people that think that they can apply foundational models to their existing AI use cases, and that will be better than actually fine-tuning it on their own data, they are strongly mistaking themselves. Would you agree with that in some sense?
But it seems, I mean, taking this more vision-based models, I mean, there it seems that the whole value is that you can actually get the parameters. So you get the pre-trained model, and then you build on top of that.
Yes.
If you only get
but
it
they are
as
not as big. They
I say that, but I mean, so I think it seems to me
they're
that
practical. You can run easily Stable Diffusion. I mean, it's you can run it on a laptop like this, no problem. So that's not at all as problematic, I would say.
So I think my argument there would be more, I can agree that if you only get the interface to send the prompts and get the kind of answer back, then probably the value is limited compared to actually having access to the model.
Yes.
And then of course having access to the model requires that you have a huge computational power. So of course the question becomes, will you be able to kind of compress them? I mean, taking the Stable Diffusion as an example, I mean, that's all, I mean, in some sense, that's even more surprising that you can decrease the computational needs.
Then you consider the practical, usability of it as well, and then it becomes really cool.
Yes.
I think we're in the start of this journey. I think we're very much in the start.
There will be a lot of new use cases that you never thought AI could be used for, given all the generative work. So it's, of course, super impressive. I just wish people had a more objective view on this and also understood the practical limitations. That's my only concern.
That's your job.
Maybe. Our job, I would say. Yours as well. Cool. Given the time, I just think we should have like one ending question here, and I'm going a bit more not psychological but societal and more philosophical, and perhaps we should just list a couple of questions and you can choose which one you would like to go
That's
more
the philosophical
into.
question.
Which question do I care for?
Okay, one would be simply the future of academic work. Some people claim there is a big brain drain from universities into big tech companies, and that research is being led in more industrial settings than academic settings. And that would be interesting to hear your thoughts about if that's true, if you agree, and if you think the universities will have a similar...
I can give you very quick, yes and no. Of course, I would say probably in some areas, taking these large scale models, yes, it's difficult to compete, but I also think that it's really important that the universities keep the competence, because there will always be limitations to what the companies find economically valuable.
Exactly.
And I think the universities needs a competence. And I really think in some sense the American model, where people work maybe half time at the university and half time at the company, is a quite good model. So I think there are also a way of combining it. But yes, there are challenges, but I think there are also very concrete ways of dealing with it.
Well said.
Well said.
If we, this is a too long topic. I'll ignore that. Okay, either a more neuro-symbolic kind of question and the thoughts. Okay, this one. Okay, so how do we reach a future in 10 years where we have more generic or more effective, useful AI systems? It can go different routes. You mentioned the neuro-symbolic approach. We could also see a number of other ways it could take. One way would be, if we take the Tesla approach, it's basically that you have an engineering way saying, we are building AI by putting it in real world in a car, for example, and then trying to also do research, but from an engineering point, and then building up what that could be, what Elon calls like real-world AI, which is different from human-level AI and different from AGI, but it's some kind of real-world AI. And that's one way to just push towards something in the future that has significantly stronger forms of AI. What do you think the path will be towards a more general type or effective type of AI?
I would actually argue maybe it's not even a technical problem. We just said earlier, before, I think there is so much value in the existing technology that we have today that's not being realized because our organizations are not equipped to take advantage of the technology.
Yes.
So in some sense, there is so much unrealized potential. which would, I mean, in order to release that potential, it's more about organizational development than technical development.
Well, that's short term. I mean, if we think, let's say 5-10 years, perhaps most organizations now realize that most development.
No, you're being overly optimistic.
I agree with you. I think this is a 10-year problem, the organizational problem.
At least.
I think
let's
it's
say 10
generation.
plus
But I mean,
in the year.
so-
Let's say there is a point where most people and organizations understand that they need to have an AI-driven approach for development or whatever product.
But I was also argued, I mean, that when companies and organizations start using it in different ways, we will also learn the ways that it does not work. So, I mean, I also think it actually reinforces the research in the sense that it provides more grounded cases where it doesn't work. But I think when it comes to research strategy, I think probably any strategy we just select one approach is probably riskful.
Yes. Okay.
And I really think it's about trying. I mean, having an open mind that we need a more basic, long-term kind of blue sky and curiosity-driven research, and yes, we do need a more applied, closer to the application research as well. And I think the danger is if we kind of fixate on only doing one thing. And when it comes to this approaches, I think probably all the ones that you mentioned are have their value.
Well said. I agree completely there. Are you optimistic then?
Yes.
Are you fearful of a singularity? Are you fearful of a point where there will be a loss of control in some way, where perhaps AI will start to, given all the generative, code generative approaches that actually AI can generate their own code and potentially then self-improve in some ways automatically? Is that something you're concerned with?
So in some sense, I would argue we already lost control, and this is our opportunity to regain control.
Oh.
I mean, you can just take the economical system, for example. I mean, the economical system that we're living in is so complex that no one really understands how it works. And I mean, how do you do and when you have, say, I mean, economic recession or something, and it's more trial and error. And I actually think by using these kind of methods, we actually can start to have a more, systematic engineering-like approach to understand and being able to control the development. And the same with, say, I mean, climate change and so on. I think, again, in some sense, it's out of control currently, and we need the tools and technology to bring it back under control so that we can actually steer it to a more positive future.
I love that spin. Answer I've heard in a long time. Yeah, I don't think we can end in a better way than that. Awesome. Fredrik, what's next in your life? What's happening coming weeks, privately, professionally, anything specific?
No, I mean, one of the things we're currently working on is, so the universities have been asked to define profile areas. So each university, they want the universities to be more specific and not to have their own kind of profiles.
Brand.
Exactly. So I'm working with one of the potential profile areas at Linköping University on AI, science and societal impact. So we're of course hoping that Linköping University will decide that AI will be one of its profile areas, and I'm leading that work.
So the profile areas is for the whole university,
yes,
so to speak, not only.
And they can only select a very small number, so probably 5.
And you want AI in the brand. That's
of
what
course,
you want.
yes. And I mean, I think it makes perfect sense. I mean, as I said, Linköping University has been pioneering AI in Sweden since the 70s. I mean, I would argue we're probably one of the broadest universities when it comes to AI research. And when I mean, we actually cover all the different aspects in one university. So I think we have a good opportunity here.
Awesome. Looking forward to hearing more about that.
That's a very good next coming weeks and months what I'm working on. I love it.
Actually, it's only until Monday, but yeah.
Anyone that you would recommend to come on this podcast?
And actually, I mean, the other thing I'm working on is that I'm been put in charge of developing several, both a joint strategic research agenda for AI research in Europe. So as I said, we have this network of excellence where I'm leading one of these networks of excellence, TAILOR, and we are together going to formulate a joint strategic research agenda. It's actually we have a meeting about tomorrow morning, So I think that's very interesting to see how should, from a research point of view, what are the things that we want Europe to
push.
Exactly. And then I'm also leading another work in an organization called ADRA, the AI Data and Robotics Association. So actually the Commission formed a partnership, a public-private partnership last year, where the Commission is investing 1.3 billion euros into this partnership, and the private side is expected to invest at least as much. And there I'm on the board of this ADRA organization, and I'm responsible for developing the next generation strategic research, innovation and deployment agenda, which we're also working on there. So there's a lot of work on the European level on setting the agenda and defining what are the things we want to work on the next couple of years.
I don't understand how you find the time to work with all these kind of initiatives that you are doing. It's insane, but it's really good to hear, and I'm glad that you are heading and steer.
And the topics
areas.
are excellent. I can see how I don't have time, but oh shit, that's something I would like to work on when the question comes.
Fredrik, anyone that you would like to recommend to come on this podcast? Someone that you would like to listen to for us to interrogate?
Interrogate.
That's how it feels.
No.
Yeah, that's a good question. You should have given me a heads up warning on that one.
I think you can come again. So that's we can end on that. We had
my second personality.
Yes, exactly.
we have wine tasting. Yeah?
Actually, but I mean, I think if you want this more legal perspective, Cecilia Sjöberg Magnusson at Stockholm University, that's always interesting because I mean it's very interesting when you have more this kind of lawyer perspective. Yes. And actually, if you want combination, because I have my colleague in Lund, Stefan Larsson, he's also a lawyer and we work together. And but he has maybe a bit more, what should I say, pragmatic rather than the kind of legal perspective. And I really think that's there's very interesting. I mean, this kind of legal aspects on AI.
And you said it before, like. We need to respect sometimes that when we have written something in an act, it's not only for the technicians to understand, but it's actually for the lawyers to be able to work on it. It's actually a quite important consideration. Yeah,
and also, I mean, how do you, educate lawyers?
Yeah.
And I mean, make them have a more, from a technical point of view, more realistic perspective. And I mean, that actually brings, there are several people, you have Jeanette Nilsson and the AI agenda. I think that's very interesting. And
she's on our list. So, yes.
And getting this, trying to get this more grassroots organization, engaging the larger community around the AI questions. And then, of course, your own area. I think the use of AI in law enforcement and so on is also very interesting. And there we have Emil Hjalmarsson at NFC. And so actually, we also did a thing at this åklagarstämman, so for all the Swedish prosecutors. So I guess that could also be an interesting to bring one of the prosecutors and say, from a prosecutor perspective, how do you view this use of AI and how can that change the way, make the courts more efficient? And then we have a
tournament. I really like the lawyer kind of view on it.
He just lifted up the game very, very high. So thank you so much.
Thank you so much.
Now we're going somewhere.
Awesome. It's a pleasure, as usual, to speak to you, Fredrik Heintz. So thank you very much for coming here. It's been a pleasure.
Thank you.
Thank you, Fredrik.